Good afternoon. Let's do this. Happy Friday. Okay. We're going to do the remainder theorem to start with. A lot of you are probably reading this remainder theorem. You know, a polynomial f of x is divided by x minus a, is the remainder is the constant f f of a. So to find f of a, you do the synthetic division with the a value, and you might be going, huh? Or maybe you're following it, maybe not. Well, let's do this, shall we? Okay. So we have this quartic function here, f of x equals 2x to the fourth minus x cubed plus 4. Show that f of negative 1 is the remainder when f of x is divided by x plus 1. Wait, what? Okay. Well, this will be pretty straightforward, actually. So we have a quartic function. We're going to need two placeholders. I think you guys should cut right to the chase. This will help you with example 7 in a second. See, this is f of negative 1. I want to put negative 1 in our box here because it says we're going to do synthetic division. Do synthetic division, it says here. We'll put negative 1 in our box. We have 2x to the fourth. We have negative 1x cubed. We have a 0x squared, a 0 for x, don't forget that one, and then a positive 4. Okay, it would be 5 terms in a quartic function. Don't forget the zeros. And let's do our synthetic division, shall we? Let's drop the 2 down. 2, and then we're going to have negative 2. We have negative 3 here. We have positive 3. Remember, you're always adding. 3 and negative 1 is negative 3. And we have negative 3, and then negative 3 times negative 1 is 3. Add that together, and we have 7. I'm going to make that nice and big. I'm going to square it. You guys ready to have your minds blown? Ready to have your minds blown? I want you to put, pretend you're in Algebra 1. Pretend you're in Algebra 1, or even Math 8. I want you to put negative 1 into this quartic function. I want you to put negative 1 in for x, the two x's here. 2x to the fourth minus x cubed plus 4. Put negative 1 in. I'll set it up. Go with that, by the way. 2 times negative 1 to the fourth minus a negative 1, watch the signs, all cubed, plus 4. What did you guys get? What did you guys get? Well, put it in. Put it in. No reason to guess. No reason to guess. You guys can do the synthetic division. You can put negative 4. I'm sorry, you can put negative 1 to the fourth power. That's easy. That's just negative 1 times negative 1 times negative 1 flips the sign times negative 1 flips it back to positive. Okay, so take a look at what did you get here? What's 2 times positive 1 minus a negative 1 plus 4? What is it? 7. Cool. Okay, example 7. Here's what I want you to do first. All right, let's cut to the chase. Pretend you're in Algebra 1. Pretend you're in Algebra 1. Forget synthetic division or anything. I want you to plug 2 in for x here. Plug 2 in for x. What do you get? Put it above the problem. Go. I didn't ask for an answer yet. Okay. So 2 cubed is 8 plus 2 squared. Do that first. Don't forget PEMDAS. It's going to be plus 20 minus 14 plus 2. What's that all equal? What's that all equal? This all equals 16. This all equals 16. So what should our remainder be? What should our remainder be if we were to do synthetic division for x minus 2, essentially? What would be our remainder if we were to do synthetic division with a 2 right here? What should our remainder be? What should our remainder be? Let's see if it is. We have 1x cubed. We have 5x squared minus 7, 2. So it doesn't look like we need any placeholders. Let's drop it down. 1 is going to be 2. For 7 is going to be 14. It's going to be 7. And then lo and behold, 14 plus 2 is 16. No, that is the remainder, but it's also the evaluation. Okay, so what's the evaluation? This is a shortcut compared to, because what if this was an x to the 5th or an x to the 6th and you had a whole bunch of terms? It's going to be way faster, especially if it's a non-calculator portion of a test. It's way faster to do this than it is to plug this in. Okay, this was easy because it was 2, and you probably have 2 cubed memorized, 2 squared is easy. But what if we had to do 12, or what if this was 12 or 13 or 14? Okay. So the remainder is going to be the evaluation. So if you were just given this, f of negative 1, and you had to plug it into this, probably putting negative 1 is easier. But if you did synthetic division, you'd still get the right answer because the remainder would be the answer. If you wanted to plug 2 into here, it might actually be easier. It might actually be easier to do synthetic division, and you'll get the same answer. Okay, so dividing by what's in the function, okay, divide by putting this in the box of synthetic division. Remember, it's synthetic division. It's not true division. If you put negative 1 in here, do synthetic division, or you put the 2 in here, do synthetic division on all the coefficients, you will get the same answer as if you plugged negative 1 into this polynomial, or if you plugged 2 into this polynomial. Wait, what are you talking about, Shriram? Shriram, it is the remainder. It is the remainder. 16 is the remainder. Yeah, we didn't ask for the polynomial. We didn't the polynomial. We did not. I'm going to put this in pencil. You're done. This is the problem. That's it. We're done. The divide the quotient is going to be x squared plus 7x plus 7. Okay, and then this is the 16 over x minus 2. But we're not asking for this. We're not asking for what I just put in pencil. We're asking to just evaluate. We're asking you to evaluate. And we're using the remainder theorem as a bit of a faster way to evaluate. That's all. Yeah, because guys, if this was like a negative 7, what's negative 7 to the 4th power? What's negative 7 to the 3rd power? Maybe some of you have that memorized, but I don't have negative 7 to the 4th power memorized. This would actually be easier if this was a negative 7. A negative 1, just plug it in. Negative 7, you might want to do synthetic division, use the remainder theorem, especially on like a non-calculator portion of a test. So eyes on the slide. Stay in the Blackboard session if you have a question. You have that new sheet, evaluate applying synthetic and long division. Why don't you guys try that on your own, like as if it's a test, see how much you know about synthetic and long division. If we ask you for long division, you got to do that. Finish all sheets handed out. Oh, thus far. Look at that, Mr. Haran. Look at that. Thus. We're going to run out of space? No. Thus far. You may work together with 15 minutes left, so take about 7 minutes. Take about 7 minutes, work on your own, gather everything, and then let me know if you have any questions in the chat box. I'm here with you.